Okay, all of these problems are from this data file here. They're the within group repeated measures ANOVA. A little background on a repeated measures ANOVA, also called a within group ANOVA, is it is less frequent than the between group. Between group ANOVA, the ones we just finished, are much more common than the repeated measures, and there is a different assumption for the repeated measures ANOVA. We'll get to it down there in a second here. But let's go ahead and read the question. So background noises affect somebody's processing speed. So processing speed is a dV. Let's keep reading. So they got 26 people, and each person performed the same tasks with 4 different levels of background noise. In other words, so they did a task at no noise, they did the same task at low, same task at medium, same task at high, and all of those times were recorded. So everybody in the study had every measurement. I'll say that again. Everybody in the study had every measurement. That makes it a one-way repeated measures ANOVA because there's only one group, but more than one measurement, right? So there's 4 measurements, one group, makes it a repeated measures ANOVA. So let's get to town here. I'm going to answer these first couple ones in a blink of an eye. I told you. So the null is always the same. No difference between processing speeds based on any of the different 4 levels of the background noise. And the alternative is, yes, there is at least one significant difference in the processing speeds between the 4 different background levels. And the IV, this is where it gets weird. Repeated measures ANOVA really don't have an IV. Just remember that there's only one group, right? There's no categorical groups here. There's only one group in a repeated measures ANOVA. What's repeated are the measurements. So each one is treated like a dV. So, but let's go down. Okay, so the dV is the repeated measure. So there's actually 3 dVs in this one, actually 4, because there's 4 different measurements. Now, the next one is we're going to check the assumptions for normality. Let's do that real quick. Jumping over to SPSS, make sure we got the right file up. And you'll see the variables are a little bit out of order here, but no noise, soft noise, medium, loud. And they are all scales. So we're going to check for the assumption of normality. Descriptives, explore, and no noise down to loud noise, dependent, and no stem and leaf, but we do want a histogram, and this is your main box here, normality plots with tests. Dun, 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 dun. And this is how many are in each one, 26. There's the means of the no noise, soft noise. There is a difference there, but let's go to the normality test. And according to this, none of the 4 repeated measures violated the assumption of normality. That's good news. So now let's run our test. And again, don't even look at the histograms. I can't even tell anymore by looking. But we're going to run the test. Here we go. Analyze. General linear model. Repeated measures. Ding, ding, ding. All right. And so we're going to name ours noise levels because there's 4 different ones. Add, we're going to define them. Oops, we have a space here. Remember, no spaces in SPSS variable names. Don't ask me why. So we're going to define them, and they're no noise, soft noise, medium, loud. And then what are we going to check? Nope, 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 nope. We could do a post hoc. No, there's a trick to that. I'll show you how to do that in a second. And we're going to go to options. We're going to go to noise levels because that's our only variable here, right? It's got 4 repeated measures. But we always want the descriptives, effect size, power, homogeneity tests. We're gonna get an error message on that because it does not look for homogeneity variance, but it does look for something we call sphericity. Okay, Now to get the Tukey test, we're going to compare the means. It doesn't offer us the Tukey test, so we're just going to take the LSD, stands for least significant difference test. We're just going to use that one instead of the Tukey test, but it should give us what we're after. Okay. So let's start reading this thing. And I just read the output as it comes along. Okay, there's our homogeneity variance test because this test doesn't look for homogeneity variance. Here's our 4 repeated measures. There's our means. So I got a high of 69 and a low of 51. That's 18. Yeah, I'm going to say there is, because if I divide the standard deviation by the square root of n, I get a standard error of about 5 or 6. And 18 divided by 5 or 6 is greater than 2. So I'm going to say, yeah, there's going to be a significant difference between the repeated measures. All right, multivariate test. This should agree with our test of within subjects box. But don't look at this now. This is a little bit advanced. But here is our sphericity test. And it did not violate the assumption of sphericity, which is good because we don't have to use these corrections. But it did not violate sphericity because this is not less than 0.05. And then here is our main box. And here are the noise levels. And sphericity was assumed, so we're just going to use this top row. And we have an F ratio of 4.26, which is significant. And it's got a pretty decent effect size, not great or anything. But there is a significant difference, and our power is plenty big. So let's go down and see our pairwise comparisons. So this one says that there was a significant difference between noise level 1 and 4. This one says between 2 and 3. And 3 and 2 and 1 and 4. So we do have some significant differences between the background noise levels. All right, normality not violated, sphericity, right? This is the Mauchly's test of sphericity. Again, this sig value is greater than 0.05, therefore you did not violate the assumption of sphericity. Yay. Gonna keep going. The F ratio, 4.26. There it is right there from your source of variance box. And there's the sig value right next to it, your effect size, partial eta squared, and your power down here on the end. Let's just answer those. So what's the probability that the null is true? That's your p-value, your sig value, and that's 0.008, which is less than 0.05. And we're going to reject the null, yes, because 0.008, that's what we call your calculated p-value. You had to go through all that work to come up with this p-value versus the alpha or the critical p-value, which is 0.05. So we're going to reject the null and say, yeah, there is a significant difference somewhere between those repeated measures. So which one had the highest and the lowest? You just simply look at the mean scores. The high was the medium noise. The low was the loud noise. Interesting. And a Tukey test. Unfortunately, Tukey tests aren't done on repeated measures, so that's my bad. But you just switch it over to the Lsd test. And that means least significant differences. And I made a table because they're all over the place. So there was a significant difference between no noise and loud noise, low noise and medium noise, and medium noise and loud noise, and the rest of them are repeats. So there's your differences of the individual repeated measures. And a one-way repeated measures Anova indicated that there was a significant difference in the processing speeds between the 4 different background noise levels, right? F, 3 degrees of, in other words, there's 4 measurements, minus 1 is 3. That's how you get your degrees of freedom on the repeated measures. And then 75 within the groups. And it came out with an F ratio of 4.26. Very small p-value, less than 0.05. It had a pretty medium effect size, 0.146. Power was over 0.8, so we're happy about that. Did not violate any of the assumptions. Yay. All right, that's it. MGZ out.